Okay, so yeah, so I wanted to just mention real quickly about the exam. So you obviously took the exam last Thursday. For the most part, it went really well, it looks like. So I was going through scores. I don't remember the average, to be perfectly honest. But I can look at it and let you guys know that tomorrow if you're interested. Um, but it looked like it went well overall. Your work should be in CrowdMark at this point. And so I am going to go through the work on CrowdMark briefly. So I'm not going to like examine every step. But if there's something obvious where you made a small mistake early, I'm going to try to catch that type of thing. Or if there's like a small typo, I'm going to try to catch that type of thing before we release the exam to everybody. Me and the other instructor using the same test, we're both doing that, and so that means that you can see the score now. You can see that I think on Friday, basically at midnight, so right after the test closed. But so you can see the score now, but you can't see what you got right and wrong yet, and that's because we're going through the scrap paper manually. Like I said, I'm not going to catch everything. So once we do release the answers, then you can still like submit a form if you think something deserves partial credit, then you can submit that and it'll be re-examined. That'll be later in the week, or at worst, it'll be early next week. But you can see your score. Your score cannot drop unless there's some issue with academic integrity. So as long as you didn't cheat, basically, then your score cannot drop. And so you should be, the score that's there is kind of the worst case scenario. It might go up. It's not likely to go up, but it's possible that it would go up based on some partial credit. Any questions about that before we start into the new content? Feel free to ask. Go ahead.
Is our score on WebAssign or on eCampus?
It's definitely on WebAssign, and it's on eCampus, but to be perfectly honest, I was going through it this morning. I didn't look to see if it was open to you guys. If it's not open to you on eCampus, it will be by this afternoon. So I'm going to update grades this afternoon for both your homework average and your test average, and then the overall score for eCampus will be updated at that point. That I'll do that before I send like the big class email for today. So when I email all you guys this afternoon, this video will be uploaded, and then also your grades will be up to date on eCampus. That won't reflect any partial credit, but that's kind of your worst case grade at this point. It might go up a little bit. Okay, other questions so far? And I don't have chat pulled up, so let me pull that up.
Whenever I go to WebAssign, it just says needs grading. It doesn't actually show me.
Okay, then check eCampus, and if it's not there yet, it will be by this afternoon.
It's on eCampus.
Okay, cool. So it is on eCampus. Okay, so a couple of questions in chat. If we have the right answer on paper, but typed it wrong on WebAssign, can you get points back? For the most part, yes, unless, so the question is, if you have the right answer written down, but the wrong answer typed into WebAssign, so it's a clear typo, can you get points back? Almost always, yes. The only time that would not be the case is if like that constitutes you really getting two guesses. So like if the answer is either -5 or +5 and you didn't know, and you typed in -5, but you have 5 on your paper, then you would not get credit for that. For the most part, that's not possible in calculus, but like as long as it's clearly a typo, then yeah, you get full credit back. You should be able to see it. So the next question is, where can you see the score? You should be able to see that on eCampus under My Grades. And like I said, if you cannot see that yet, you will be by this afternoon, and I will send an email. And the next question is your grade supposed to be on WebAssign? Okay, apparently it's not on WebAssign, but it is on eCampus. And then if you missed a negative, I'll have to look. So the question is, if you missed a negative, would you get partial credit or credit back? You would at least get partial credit, but I would need to look and see exactly what the issue is, like what the problem is as far as whether you get full credit. Probably not full credit, but probably most of the points back, depending on the scenario. Okay, any other questions about the exam or grades or any of that? We have to submit midterm grades tomorrow by noon, so you will get a midterm grade for the class. I think you guys will be able to see them a couple days after that, so probably by the end of the week. You'll get a letter grade based on your two exam scores, and then your homework and quiz average up until exam 2, which will be updated, like I said, this afternoon. I'll email everybody, with the homework for today, and then saying this video has been posted, and then explaining about the grades. But all of that will be updated at that point. Any other questions before we go on? Okay, so that's where we are right now. The next topic in the course is what's called sequences and series. A lot of you have probably heard that Calc 2 has the reputation of being the hardest of 4 semesters of calculus, or at least 3 semesters of calculus and differential equations. Most people think that's the case. I'm not sure that I agree with that, but most people think that's the case because of sequences and series. And that part I definitely don't agree with. I think that the hardest part of Calc 2 is actually integration techniques, which is the test that you guys just finished up. So being able to tell the difference among the different integration techniques and being able to experiment with those, I think that's the hardest thing. Sequences and series is typically what people refer to as what makes Calc 2 so much harder than the others. And I do think they're genuinely not right about that. But I do want to give you heads up that the reason a lot of people tend to have trouble with sequence series is 2 reasons. One is it's kind of a new type of thinking. So most of what you've done in math up to this point, probably not the same as what we're about to do. I don't think that means it's harder. It's just you have to be able to look at it kind of in a different way. And then the second big thing is what tends to happen is people will fall behind on sequence series. And if you do that, it's very, very difficult or maybe impossible to catch up. And so what you definitely need to be doing is when we're doing these videos, or when we're doing these live lectures, if you can attend live lectures, it's even more important now to do that. You guys are all doing that, so that's great. But it's more important, if possible, to attend live lectures, because if you don't understand something, it's very important that you understand every little detail before we move on, because the material builds very quickly. So the reason a lot of people think this is so hard is because they tend to miss something early. So maybe they don't do the homework right on time, or, and I understand that, if you have a test or something, you have to push stuff off, but you guys really need to stay up on this every single day because it will build fast. It's not that it's crazy hard. It's just that if you miss something in the beginning, it's incredibly difficult to catch up later. So I really need you guys to stay on top of stuff. So every little example, if you have a question, please do not feel dumb asking. You should ask, unmute yourself, ask, or if you don't want to unmute yourself, you can ask it in chat. And I thought it was set so you could do it. You can do that publicly or just to me. It doesn't matter. I won't single you out or whatever. So please, please ask. So we're going to start talking about sequences, and then we'll talk a little bit about what a series is. And today is kind of just an overview, but we do need to understand every single thing today before we move on to tomorrow's stuff. And you need to kind of watch that as we go through all of this, that if there's some small thing you're not sure on, please, please ask. Okay? All right. So the first thing we're going to do is something hopefully easy. So a sequence is something like this. And so what's next? Oh man.
6.
Okay, very good. So 6, and then 7, and then 8, and so on. And this goes on forever. So that's an example of a sequence. Another example of a sequence is something like this. So if I have 1, 4, 9, 16, 25, 36, 49, and so on. What are the next 2 terms in that sequence?
64 and 81.
64 and 81. These are perfect squares. Does everybody see that? Okay. Another one would be if I have 16, -8, +4, -2, +1. And this is trickier, but what's the next term?
Negative one half.
-1/2. Several of you got that. That's good. And then after that would be what? So negative 1/2 would be next.
1/4.
Positive 1/4 would be next, and then negative 1/8 would be next, and then that would continue forever. Does everybody understand that? Everybody clear? Okay, so these are examples of what a sequence is. The book defines a sequence as an ordered list of numbers. We're going to be a little more specific the way we define a sequence, but they define it as an ordered list of numbers. We're going to define it a little bit differently. We're going to define, it turns out it's equivalent, but we're going to define it a little more exactly than that. So a sequence, just one, a sequence, we're going to define as a function. And whose domain meets certain conditions. And so I'm going to fill this in a minute. But I want to look at that first sequence. Or not the first sequence, but the one that's now showing at the top of the screen. 1, 4, 9, 16, 25, 36, and 49. Okay, so it should make some sense that we could describe, you know what, we're going to do this up here. Let's erase this one. And let's talk about this sequence. Okay, so it should make some sense that we might be able to describe this sequence this way. Everybody see that, how that might correspond to this list? Everybody get that? Okay, so if I use that notation, an equals n squared, a sub 1 is 1 squared, which is 1. A sub 5 is 5 squared, which is 25. It works just like function notation, except it's a subscript. Does everybody see that? Okay, a normal function, and remember, we're saying a sequence is a function, okay, but normally the way we've talked about functions before now is we would have something like f of x equals x squared, and f of 1 is 1 squared, which is 1. F of 5 is 5 squared, which is 25. And so this notation on the right works basically the same as this notation on the left, where we are, except instead of f parentheses 1, it's a sub 1. Instead of f parentheses 5 or f of 5, it's a 5 or a sub 5. Does that make sense to everybody? Okay, what is the domain of a function, or what does that mean? Somebody want to tell me? What's the domain of a function?
All the possible x values?
Yeah, all the possible x values. So the domain of the function on the right is negative infinity to infinity, meaning you can plug in any real number, any number from negative infinity to infinity, you can plug any of those in for x and get an answer. Does that make sense? Everybody understand that? Okay, for sequences, the domain is not all real numbers. So it's still a function, but its domain has implied restrictions on it. It's the set, whose domain is the set, and we're not quite done. It's not the set of integers, but I want to say, what an integer is. Who remembers what an integer is? An integer. So like, is 5 an integer?
Yes.
Yeah. Okay, is -2 an integer? Yes. 0 is an integer. 1.2 is not an integer. 1/2 is not an integer, but -6/2 is, because it's -3. So integers are these numbers. Basically all of the whole numbers and the negatives of those, and their opposites. So nothing after the decimal point if you write it as a decimal. Does that make sense to everybody? Okay, so the domain is the set of integers greater than or equal to some integer. And usually we specify that, although we don't have to. So when I defined this sequence up here, I might have said, okay, a sub n equals n squared, where n is greater than or equal to 1. But that might be implied by what I wrote as the sequence on the very top line. Does that make sense to everybody? Okay, so it's the set of integers greater than or equal to some integer. Okay, here it's the set of integers greater than or equal to 1. But by definition, we don't need to state that the domain is the set of integers. That's implied when we use sequence notation. Does that make sense? Everybody clear? Okay, so that means that f of x equals x squared and a sub n equals n squared are very, very similar. But if I talk about f of, say, 2.5 over here, and I talk about a sub 2.5 over here, I want you to take a minute and write down on your paper, if you're making notes or whatever, think in your head what those are equal to, and then check it with me in like 30 seconds. Okay, so f of 2.5 is 6.25 because it's 2.5 squared. A sub 2.5 does not exist. Okay, so it does not matter that you can calculate 2.5 squared. We know we can calculate 2.5 squared. Here, that's not part of the domain. So it either does not exist, or you can say undefined, but that is not part of the sequence. Does that make sense to everybody? You clear? Okay, a sub -6 and f of -6. Obviously over here, f of -6 is positive 36. A sub -6 does not exist on the left. Okay? In general, could a sub -6 exist on a different sequence? So if we defined a different sequence, could this exist sometimes? Yes, because you could start somewhere earlier than -6. It just says greater than or equal to some integer. So if I hadn't said n greater than or equal to 1, I could say n greater than or equal to -10. And the way we're defining a sequence, yes, you could make a sequence where this would exist. It does not here. Does that make sense to everybody? Okay. Could a sub 2.5 ever exist the way that we're defining a sequence? No, because a sub 2.5, 2.5 is not an integer. Does that make sense to everybody? Clear? So a sub 2.5 would never exist. A sub -6 might on a different sequence. Okay? Any questions so far? Okay, so now I want to talk about the graph of the sequence on the left versus the sequence or the function on the right. So if I were to graph this function and this function, again, remember they're both functions. If I graph f of x equals x squared, I think all of us know it looks something like that, right? Okay, not a perfect graph, but looks something like that. If I were to graph a sub n equals n squared, again, I want you to take 30 seconds and jot down what you think the graph of that looks like. and then check it with me in a second. Okay, so if we graph the sequence, we have the 0.11, which might be like about there. We have the 0.24, which is about there. 3.9, which is going to be up here somewhere. 4.16, which is going to be way up on my screen from there. 5.25, and so on. And now what else should I do other than draw those 3 dots? Should I connect them? I should not connect those because there's nothing between those. So it's just a sequence of dots along that parabola. Does that make sense to everybody? If I zoomed way out, it would look like this. So if I zoomed way out, it would look like that steep parabola, or fairly steep parabola, but a sequence of separate dots. Everybody clear? Any questions so far? Okay, so a couple things about sequences. One is that in calculus, the presentation of sequences assumes you've seen them a little bit. I'm going to assume for the most part that's not true. And so we're going to do it as much as possible as though we've never seen it. But some of the pre-calculus stuff with sequences, we're going to have separate sessions or separate review sessions in order to do that. So one thing that you're expected to know how to do is be able to use this notation. So like a sub 5, you should be able to find 5 squared. I'm going to assume you're probably good with that without me having a separate session on it. Another thing that most textbooks, and our textbook especially, assumes that you're able to do that I may not assume is that you're able to come up with a formula for this given the list of numbers. So if we give you a list of numbers, that you can then come up with a sequence formula for that. I will either have a review session for that if you want to study more of that, or I'll probably more likely what I'll do is I'll post a video that I make where we review some techniques on how to come up with formulas for sequences. So most textbooks, and our textbook assumes that you can kind of figure that out on your own. And so I'll probably make a video, or I think I have a good video that kind of reviews how to do that. But the pre-calculus stuff, the stuff that does not involve derivatives, integrals, and limits, which is the calculus part. The pre-calculus stuff is assumed that you kind of have those ideas already. And so like plugging it in, graphing it, given a list of numbers, coming up with a formula, those things, they assume you know. I will review as much as possible during the regular lecture for that. But when there's something that maybe is from before that I assume probably most of us don't know, but because of time we can't do in the regular lecture, I'll try to have a separate video for that. And I'll let you guys know when those are available and where they are. You don't have to watch the videos, but if it's something where you know you need to practice, you can do it. But the point of bringing that up now is that the calculus part of sequences is what we start to study. And so calculus, the basic study of calculus so far has been limits, which are the basis of derivatives, and then the opposite of derivatives is antiderivatives, or limits, derivatives, and integrals. And so we actually kind of follow the same type of thing here. We start with limits, and then derivatives and integrals are a little less important for sequences, but we'll actually get into those ideas later. An integral of a series or sequence you might think of as a series, and that's not exactly the same, but we'll kind of talk about the connections there. But the first thing we really talk about is limits. So I want to come back to these pictures in a second. But if I was talking about a limit in Calc 1, if we have this function that looks like this, so this weird function, and they do a lot of these diagrams in Calc 1, I think. All right, and so let's put a dot here. And so let's say, okay, this is the point where x is 4, and this is the point where x is 7. And the y value at this bottom one is 2. The y value at this one is 4. At this middle one is 5. And this top one is, well, this one is 6, and the very top one is 8. All right, so I'm purposely not, my picture's not perfect, but I want this x4 to correspond to all three of those, this x7 to correspond to both of those, and then the y values to correspond to the ones that it looks like they correspond to, or roughly look like that. Okay, and so if we're talking about in Calc 1 or in general, if we talk about what is f of 4, what is f of 4? And you know what? Yeah, f of 4 is 5, and I'm going to add another point there in a second. Okay, and then the limit as x approaches 4 of f of x, and obviously we're assuming this graph is f of x. What is that? What's the limit as x approaches 4 of f of x?
Undefined.
Yeah, it doesn't exist, or it's undefined. And so this limit, we say it doesn't exist. And why is that? Why does the limit not exist when f of 4 is 5?
Because as it approaches on the left and the right, you have two different numbers.
Yeah, so as it approaches it from the left and from the right, you have two different numbers. So the limit as x approaches 4 from the negative side, or from the left is the way you read that, but I was thinking of it from the negative side, from this. So from this side, the limit as x approaches 4 from the negative side is 4, because that's what the y values are getting close to. The limit as x approaches 4 from the positive side is 6. And so because these two aren't the same, then this doesn't exist. Does that make sense? Okay, now what about at 7? So what's f of 7 in this diagram? So f of 7, is that 2 or 8 or something else?
2.
2. Okay, so f of 7 is 2. And what's the limit as x approaches 7 of f of x on this?
Like 8 or?
It's 8, yeah. Or maybe just below, because I didn't draw it perfectly. But yeah, the limit as x approaches 7 is 8. And so what about from the left and from the right? So limit as x approaches 7 from the left. Man, that's supposed to say limit. And limit as x approaches 7 from the right of f of x in both cases. What are those? So from the left, what are the y values doing? Getting close to 8. And then same from the right. So these are both 8. So the definition of this limit as x approaches 7, that's if these two are the same, if the limit as x approaches 7 from the left and from the right are both the same, then that's what the limit is. If they're different, then this doesn't exist. How much does this statement have to do with the function values? So does this, how much does this 8 have to do with this 2? None. This limit has nothing to do with this function value. Does that make sense? Okay, this is related only to what's happening immediately to the left and immediately to the right. Has nothing to do with what happens right there. Now, if these happen to be the same, then we say it's continuous. If these aren't the same, then it's weird, discontinuous, which is why you have this weird thing happening on the graph. If I looked at this point, if I said, okay, that's 3, 2, then all 4 of these would be the same. The limit from the left, the limit from the right, and f of 3, and the limit would all be 2. That's continuous. That's what happens at most points. But at weird points, then okay, one of these, at least one of these is different from the other. That means it's discontinuous. That's something that you talk about a lot in Calc 1 and is real important. But the key here is that this limit has absolutely nothing to do with the function value, nothing at all. Does that make sense? Everybody clear? Only has to do with what happens immediately to the left, immediately to the right. Let's go back up here. Okay, and so now a sub 2, remember this is a sub n equals n squared. Okay, so a sub 2 is obviously what again? A sub 2 is clearly
4.
4, good. So a sub 2 is 4. What about the limit as n approaches 2 of a sub n? What do you guys think? Take 20 seconds and write down what you think the answer is. And if you're wrong, fix it with me in a second. Okay, but think about it. Tell me what you think, or write down what you think the limit as n approaches 2 is of that sequence. What do we think? Anyone have a guess? Yeah. So somebody in chat just told me does not exist, which is the right answer. The only legitimate guesses, I think, are that or 4. And I can see why we would think 4, but why is 4 wrong? What does the limit have to do with, again, down here? When we're talking about the limit as x goes to 7, we don't care about what the y value is at 7. Does everybody see that? We care about what happens at like 6.999 and 7.0001. Okay, so on this graph, you've got 2, 4. What happens immediately to the left of that? Nothing. There's nothing there. A sub 1.999 does not exist. Immediately to the right of that, 2.01. A sub 2.01 doesn't exist. It's not like we're just not filling in parts. There's nothing between 1 and 2. There's nothing between 2 and 3. Does that make sense to everybody? So this limit doesn't exist. Now, I'm not going to make my picture big enough to see this one on the graph, but what do you think the limit as n approaches 100 or n approaches 275,341 of a sub n is? I mean, I guess we could draw 275,000 dots, but what do you think that limit ends up being?
DNE.
Doesn't exist. Why does this not exist? There's going to be nothing around that dot either. Does everybody get that? So there's nothing immediately to the right and immediately to the left. So, okay, limits are a huge part of calculus. The limits of all of these don't exist. Does everybody see that? So there's really, based on this definition, there are no limits that would make any sense except one limit. Okay, so there is one limit that might make sense. What do we think you could talk about? What limit maybe could we mention? So like the limit as n approaches 2 doesn't make any sense. The limit as n approaches 5 doesn't make any sense, doesn't exist. Limit as n approaches 0 doesn't exist. What
Infinity.
Infinity, yeah. So we could talk about the limit as n approaches infinity, because the way the domain works, n is always going to go to infinity. The set of integers greater than or equal to some integer n always goes to infinity. The sequence might not, but the subscripts do. And so we could talk about that. In this case, it should be clear from what we know about limits that we would describe that limit as infinity, even though technically that still does not exist. So in this case, the limit is infinity. The numbers 1, 4, 9, 16, 25, 36, and 49, those go to infinity. We use a different word to describe that now. Rather than saying it doesn't exist, we say it diverges. Okay, so we use the word diverges if the limit does not exist. But we will talk a lot about the limit as n goes to infinity. Does that make sense to everybody? Okay, so I want to go back and talk about, oh, the one I erased. So we're going to go back down here and talk about several sequences. So if I have this sequence, if I say I've got 16, -8, 4, -2, 1, -1/2, 1/4, -1/8, and that goes forever. I think that's the same one I had earlier, or it might have been the opposite negatives. But that sequence, as n goes to infinity, the limit of that is not infinity. What do you think happens here if this is the sequence an? As n gets really, really big, so maybe this is a1, this is a2, this is a3. So like if a is 5 billion, or I'm sorry, if n is 5 billion, if we're talking about a sub 5 billion, or n is something way bigger than 5 billion, what are those terms doing? What do they approach infinity? Do they not approach anything?
Approaching 0.
They're approaching 0. So the limit of this sequence is 0. When n is 5 billion, you have 1 over an incredibly large number, which is basically 0. Or maybe you have -1 over an incredibly large number, which is still basically 0 or incredibly close to 0. Does that make sense? Everybody clear? Okay, so we say that we write this notation. We write limit as an, or as n approaches infinity of an equals 0. We're also going to write that this way. And so I'll use this notation a lot to mean this. And the reason this notation is okay is because it's understood that anytime we're talking about the limit of a sequence, we're talking about the limit as n approaches infinity. Does that make sense to everybody? Okay, so we're talking about the limit as n goes to infinity. That's understood. So this notation will mean the same thing. We can also say an converges. Man, that's an n. Let's make that actually legible. An converges to 0. All three of those statements mean exactly the same thing. So the limit as n approaches infinity of an equals 0. An arrow 0, that's still the limit as n approaches infinity of an equals 0. And then an converges to 0. All of those mean the same. Does that everybody follow that? Any questions? Okay, so we're going to look at a few problems where I want us to list 4 terms of the sequence. Guess whether the sequence converges or diverges. If it converges, guess its limit. Okay, so the first one is a sub n equals 1 over n. And we're going to assume n starts at whatever's convenient. So the way that, you know what, no we won't. We'll just say for now, n greater than or equal to 1. Tomorrow or in the next lecture, we'll talk about why maybe that beginning value doesn't matter that much. But for this one, it would. So, okay, if we list 4 terms of the sequence, a sub 1 is 1, a sub 2 is 1/2, a sub 3 is 1/3, a sub 4 is 1/4. And so if we wanted to write it as a list of numbers, we could write it that way. Either way is fine. There's nothing about these instructions that means I need to write it sideways, but you can. But these are the first 4 terms. Is everybody clear how to do that part? Pretty easy. Okay. And so we're going to guess whether that converges or diverges, meaning guess what the limit is as n goes to infinity. So as n gets really, really big, what's happening to these? So we have like 1/5, 1/6, 1/7, 1/8, 1/9. What's happening as n goes to infinity? Or what is the limit of that?
Numbers are getting really small.
They're getting really small, and that meaning they get really close to what?
To 0.
It approaches 0. And so as because like 1/5, 1/6, 1/7, those are really small decimals. 1/10 is like 0.1. By the time we're at 1/100, it's 0.01. Does that make sense to everybody? And so what we say is, okay, we guess that the limit as n approaches infinity of an equals 0, which means we're saying it converges to 0. Does that, everybody follow that? Question?
Yeah, but why can you just like not count the like to the left of 0 since that's not really there?
Because we're not, so okay, we're talking about the limit as n goes to infinity, not as something approaches 0. So the y values are approaching 0. Does that make sense?
Yeah, that makes sense.
Okay, cool. And so like back up here, it's the same deal as this. Like here, it's what the x is around 7, not the y is around 8, or not the x is around 8. It's like it happens to end up being 8. Has nothing to do with the 2. Does that make sense? Okay. All right, everybody clear on this? So as n goes to infinity, we're just talking about to the far right of the sequence. So as you keep moving to the right, as n gets bigger and bigger, what happens to those numbers? Okay, and so then problem 2 is going to be a sub n equals, let's do 1/3 to the n for n greater than or equal to 0. And so a sub n equals 1/3 to the n for n greater than or equal to 0. So a sub 0 is 1/3 to the 0, which is 1. A sub 1 is 1/3 to the first. A sub 2 is 1/3 squared. A sub 3 is 1/27. And so we have the sequence 1, 1/3, 1/9, 1/27, 1/81 is going to be next. And again, we're going to guess that this one converges to what? Do you guys think? These are again getting close to 0. Does everybody see that? Any questions?
Wait, so does converge mean it goes to 0, or is there?
Yeah. So converge means the limit exists. So it means that the limit is 0, or limit is something else. So a question I think you're actually asking is, does it have to be 0? And then somebody in chat also, so Gabrielle is asking, is the only way for it to converge for it to be 0? And no, it's not. And so let's look at an example where it converges to something else. But these two, is it clear why these converge to 0? Everybody good? Okay. All right, so number 3, I'm actually going to write the terms this time. So we're going to just say, okay, an is equal to the sequence, and it's going to be 0.9, comma 0.99, comma 0.999, comma 0.9999, and so on. So I've listed the first 4 terms for us. But what do we think this does? Does this converge or diverge? And if it converges, what do you guys think it converges to? So converge or diverge basically means, it does mean, is there a limit or not? So converge means there is a numeric limit. Diverge means there is no numeric limit. And so is there a limit here?
Wouldn't it be 1?
Yes. So this limit of this one is 1. So we would guess that AN converges to 1. Notice I'm saying yes. We haven't proven any of this, but it's fairly clear on these that it's converging to 1. Does that make sense? And then does that answer, I don't know who asked the question out loud a minute ago, and also Gabrielle, does that answer your question?
Yeah.
Okay, cool. And Gabrielle in chat, does that answer your question? Okay, cool. All right, any other questions so far? Okay, so now we're gonna do 2 more like this. And so, okay, AN equals 3 minus N for N greater than or equal to 1. And number 5 is A sub N equals -1 to the N for N greater than or equal to 0. So I'm actually going to give you a minute to list at least 4 terms of those and see if you can guess what the limits are, and then check with me in just a minute. Okay, so if we do this one, A sub 1 is 2, A sub 2 is 1, A sub 3 is 0, A sub 4 is -1, A sub 5 is going to be -2, and we only were asked to list 3 terms or 4 terms, is what I said in the instructions, but listing some more makes it more clear. So there's at least 4 terms. What do you think this one does? What's the limit as n goes to infinity on this?
-infinity?
Negative infinity. So the way we can write that informally is we could say, okay, an goes to negative infinity, but that means that the sequence diverges. Okay, so when I say that converges means that there is a numeric limit, that means the limit exists and is a number. So the limit is 1, or the limit is 0, or the limit is 2/3, or whatever it is, but it's a number. When you say that the limit is negative infinity in Calc 1 and now, that's not only not just, it's not a number, but the limit still does not exist. And so a lot of times that gets a little bit confused in Calc 1 because you say, okay, well, the limit is negative infinity, and it is, but when it's infinity or negative infinity, technically still the limit does not exist. And the word for that for a sequence is that it diverges. Does that make sense to everybody? Questions? Okay. On number 5, a sub 0 is 1. A sub 1 is -1. A sub 2 is 1. A sub 3 is -1. And so this is the sequence 1, -1, 1, -1, 1, -1, 1, -1, and so on. And so, okay, does this sequence converge or diverge? Real quick, we know it's this because -1 to any even power is +1. -1 to any odd power is -1. So we know it does that. So what do we think? Does that converge or does that diverge?
Diverge.
It diverges, and it doesn't, obviously it doesn't go to infinity or negative infinity, but we say it diverges because it never gets close to a single number. So for the limit to exist, it has to get closer and closer to one number. So here it gets closer and closer to 1. On the ones above that, it got closer and closer to 0. This one doesn't get close to infinity, doesn't get close to negative infinity, but it continually bounces between 2 separate numbers. Does that make sense to everybody? Any questions?
Yes. Do we say that does the limit approach anything, or we just leave it as the
Doesn't.
limit does not exist?
The limit, so diverges means the limit does not exist. And Santi, what I'm writing here is actually informal. We usually will describe it and say that it goes to negative infinity, but still the answer to this is no different. The final answer to this is no different from the final answer to this. The reasoning why is different. Does that make sense?
Got it. Yes.
Okay, cool. And then up here, when we're saying this, remember that notation, when I write that is the same thing as writing this. And it's also the same thing as writing this. So if we did give you guys questions on WebAssign or on a test or a quiz or whatever, if we say, does the sequence converge or diverge, and you have to check one of those, this one converges, this one diverges, this one diverges. When I'm writing AN arrow 1, I'm implying that the answer converges. The answer to that is converges. But when they converge, they have a limit. So we always also try to say what it converges to. So what the limit is, okay? So if I say, what is the limit and what does it converge to? That's basically the same question. That is the same question, okay? And same back up here. These two converge and these two both converge to 0. When we say diverge, we're saying it doesn't exist. So you don't technically say that it diverges to anything because you're saying it doesn't go to anything. So then it diverges. Informally, you can say negative infinity, but it's not technically correct to say diverges to negative infinity. That's not something that we actually usually say. We just say it diverges. The reason why it diverges is because it tends toward negative infinity. All right, any other questions to here? Remember, this does build, so it's going to build in just a minute. So
I'm sorry. Why
go
does
ahead.
the first one converges?
I'm sorry, which one?
Number three.
Number 3?
Yes.
Why does that converge?
Yes.
Okay, because as you keep going, we're going to just get more and more 9s. And so like by the 10 millionth term, we're going to have 0.10 million 9s, which is incredibly close to 1. Does that make sense?
It doesn't have to be 0. I mean, it doesn't have to converge to 0.
Right. So if it converges, it could converge feasibly to any number. Does that make sense?
Okay. Yes, it does.
Okay. And again, it's the same idea as a limit. So if the limit exists, a lot of times limits are 0, but they don't have to be 0. And same thing here. A lot of times when we're dealing with them in practical situations, a lot of times the limits are 0, but they don't have to be. They could approach something else. And we could get formulaic ones, and we will get ones where I give you a formula where it's not 0. And so we'll get more into that in the next few days. All right, other questions to hear? So please ask. This is really good. I want you guys asking this stuff. All right, good so far? Okay, so we're gonna look at a real weird sequence. We're gonna look at 2 sequences. We're gonna look at this sequence, A sub n equals positive 1/2 to the n, and we're gonna say n, let me check real quick. I wanna make sure it's a little bit different from this one. N greater than or equal to 1. And then we're going to define a different sequence, S sub n, in a weird way. Okay, so now both of these are sequences, and I want to just talk about first how to get terms in the sequences. Okay, so I want to talk for a second about how to get terms in the sequences. So on the left, A sub 1 is pretty clearly 1/2. A sub 2 is 1/2 squared, which is 1/4. A sub 3 is 1/2 to the third, which is 1/8. A sub 4 is 1/2 to the fourth, which is 1/16. And so we have this list, oops, not 1/2, 1/4, 1/8, and 1/16. And we can make a quick guess that this converges to 0. And that's like the ones we've been doing. Does that make sense to everybody? Any questions? Okay, now the one in blue on the right, I want us to look at that without regard to this for a minute. So just looking at the one on the left, on the right, I want to talk about how we get these terms. So I'm going to actually skip, and you know what? I'm going to do the terms in green. No, never mind. S1, S2, but I want to skip the first two for a second because it makes more sense for S3 at first. Okay, so S3, when you look at this subscript, I want you to think for a second and jot down what you think the answer to this is. But looking up here, you have N, you have K, you have S. So there's a lot going on in this notation. What is 3? Is 3 S? Is 3 N? Is 3 K? Is it all of those? None of those? So what variable is 3 replacing?
N.
N. So N is 3. So like over here, when we're doing A3, we're replacing this N with 3 and then evaluating. That's actually what we do here too. We're going to replace this N with 3, and that's the only place N shows up in the formula over here. So it says you have this sigma K equals 1 to 3 of 1/2 to the K. And so that's what this means, just like A3 means 1/2 to the third. Now over here, okay, we do 1/2 to the third and figure out what it is, and it's 1/8. Here, we use sigma notation. This means add from K equals 1 until K equals 3, where you plug all those in. So it means, okay, plug in 1 for K, plug in 2 for K, plug in 3 for K, add them up, and stop at 3. So we get 1/2 to the first plus 1/2 squared plus 1/2 to the third. And we stop at 3. Is everybody comfortable with sigma notation? We've seen that in a course somewhere, I think. But if not, no big deal. We've hopefully seen it in Calc 1, but maybe Stat, maybe some other science classes. Everybody clear on what I'm doing there? Okay, so 1/2 to the first is 1/2. 1/2 to the second is 1/4. 1/2 to the third is 1/8. And if you add those up and get a common denominator, you get 7/8. I want to take a second and find S4, but does everybody follow that? Please ask if anything's unclear. It's okay if you don't remember how this works. Okay, so S4 is the sum from K equals 1 to 4 of 1/2 to the K. So we plug in 1 and get 1/2. We plug in 2 and get 1/4. We plug in 3 and get 1/8. We plug in 4 and get 1/16. And we stop at 4. Does that make sense? If we get a common denominator here, we get 15/16 as the answer. So we get 15/16 as S4. I want to go back and get S1 and S2, but is everybody clear how these are calculated? Okay, so S1 is the sum from K equals 1 to 1. And we just didn't start with that because there's not much that actually happens there. So you plug in 1 and you stop and you get 1/2. And then S2 is K equals 1 to 2, so you plug in 1 and 2 and stop. So you get 1/2 plus 1/4, which is 3/4. Okay, so again, technically what happened is the same thing as over here. It's harder to calculate these. And you get this list: 1/2, 3/4, 7/8, 15/16, and so on. Let's make that actually look like a 3. But this is 3/4. And so you get this list. Does that make sense? What does it look like that list is doing? Is that converging or diverging, or can you not tell? It's definitely not converging to 0.
Converging to 1.
Yeah, I think it's converging to 1. And so we're going to guess that it's converging to 1. If you think it's going to get bigger than 1, at this stage, that's reasonable. So when you're doing these problems, and I'm going to have you do a couple for a take-home quiz, we'll talk about that in a minute. When we say guess whether it converges or diverges, you don't have to guess perfectly right. If you think this diverges, or if you think this is getting close to 1.5, that's completely reasonable. Does that make sense to everybody? It turns out we will prove next week that this converges to 1. We're able to prove that. And if you list a few more, I think it's going to become more clear that it's converging to 1. But if you think it's converging to 1.5, okay, you're allowed to guess wrong, but you have to guess reasonably wrong. And so if you say diverges, fine. If you think this goes to 1.5, fine. If you think this converges to -3, you're wrong. Does that make sense? And I'm not trying to be a jerk. I'm trying to be funny, but apparently not succeeding. Does everybody understand that? All right. So this does not converge to -3. This converges to 1. Maybe it converges to 1.5. We don't know that. But you have to guess something reasonable. Same thing over here. If you think this diverges for some reason, okay, maybe. Or if you think it goes to -1/2, okay. But if you put that it converges to 12, there's no reasonable way to think that. Does that make sense to everybody? All right. So you can guess, and you can guess wrong, but you have to guess reasonably. You have to have some justification for that if you're not sure. Okay, and it's okay to say you're not sure, but this is why I'm not sure. And so, okay, the one on the right is an example of what's called a series. And we're going to talk a lot more about those later. It's a specific type of sequence. It's still a sequence, but it's defined by adding up this other sequence. Does everybody see that? So like S3, you're adding up 3 terms in this. And so I want us to experiment with this stuff. I want us to get good at just writing the terms for both a sequence and a corresponding series, and then guessing whether they converge or diverge. And so I want to show you the first 2 handouts in the shared drive. There are 2 in the Unit 3 folder. So Unit 3 is now up on the Google shared drive. Man, that's supposed to say drive. Unit 3, and then folder 1 is sequences. And there are 2 handouts in there. All right, and so let me show you those 2 handouts. Let me actually pull it up though. Oh, Unit 3. All right, and so you've got these 2 handouts. You've got Intro to Sequences series. So this handout says, okay, you've got a bunch of formulas, and it says write out the terms A1 to A6 of the sequence. So instead of the first 4, we're writing out the first 6. Without a proof, make a guess as to whether it converges or diverges. If it converges, what do you think it converges to? Or what is the limit? So like what we were just doing. And then, okay, S1 to S6. So add from 1 to 2, or 1 to 1, and 1 to 2, and 1 to 3, up to 1 to 6. So do what we were just doing for that one on the right, and then make a guess as to whether that sequence converges or diverges. And if it converges, what does it converge to? Now, there are 16 of those. ideally, you would do all of them, but that would take forever. And I understand not all of us are going to be able to do all of them. And I'm not giving you answers to these. These are to experiment with. So you should do as many as you have time for so that you're comfortable with this process. The second handout is the required one. And so this is a take-home quiz. And this one, notice it starts at 0 instead of 1 on both of these, but it's A0, A1, A2, up to A6. For this sequence and for this sequence, so just 2 of them. And then part B, without a proof, make a guess. And then S0 up to S6 for the same idea. And without a proof, make a guess as to whether that sequence. Again, your guesses can be wrong, but they have to be reasonable. And so these 2 we're handing in for a quiz grade on CrowdMark. CrowdMark emailed you like right before class with that, and it's due tomorrow night. Or if you're watching this on video later, it's due Tuesday night at 11:59 p.m. And so you should submit that on CrowdMark. I want to talk for just a second about what this is telling you. So I'm going to jot down like on number 1 is not exactly the same as the one we just did, but it's very close. So it tells you this, and then on part C, and I'm going to write this on my screen, and then this is what part C says, and I just want to tell you how to interpret what that's saying. Okay, and so let me share my screen again real quick, my iPad screen. All right, and so this is what's given on the actual problem, this AN equals 1/2 to the N. And then in the instructions for part C, it's saying this. So AK means this formula with K in place of N. So you would rewrite this as the sum K equals 0 to N of 1/2 to the K. So this is exactly the same as the one we just did, except that it starts at 0. And so that will affect all of them on part C and D. That will not affect part A and B much, but it will affect C and D a lot. So it starts at 0, but this is what I mean when I'm writing this. And so it's just like use all those formulas there with K in them instead of N. Sorry, so definitely do the 2 take-home quiz ones before the next lecture. So if you're coming live tomorrow, do it before the live lecture. If you're going to watch the video recorded, that's fine. But do the take-home quiz. Make sure you're comfortable with this idea before then. If you have time, do some of the ones from the practice sheet. I'm not collecting the practice sheet, but the take-home quiz, obviously, I am collecting. And so you need to submit that on CrowdMark by tomorrow night. All right, that's it for today. Sorry I took so long. That is the first time we've taken the whole time in a while, I think. But that's it for today. Thanks for coming. If you have questions, stick around. If not, I will hopefully see you tomorrow.